Assalamu alaikum wa rahmatullah. In this video, we are going to solve two problems about chapters 3 and 4, emission and reception of sound. But before, let's take a look about the most important ideas in this lesson. First, let's solve problem number 14 from the book, page 63. A sonar equipped with an ultrasound emitter receiver of frequency 100 kHz sends in C waves brief pulses of 10 milliseconds each. The speed of propagation of ultrasounds in seawater is 1500 meters per second. The question is to determine the position of the obstacle, knowing that the first echo is received just before the emission of the second pulse. We know that the time taken by the first impulse to cover the to and fro motion is 10 milliseconds. That means the emitted wave needs in reality 5 milliseconds to reach the obstacle, and its echo needs also 5 milliseconds to reach the sonar before the other wave is emitted. So the time taken by the first impulse to reach the obstacle is 5 milliseconds, and we are going to use this interval of time to calculate the distance between the obstacle and the sonar. So the position of the obstacle is d is equal to speed multiplied by time, which is equal to 1500 meters per second multiplied by 5 times 10 to the power minus 3 is equal to 7.5 meters. Then the obstacle is 7.5 meters far from the sonar. Problem number 15. A dolphin possesses a natural sonar which emits and detects ultrasounds of frequencies up to 200 kHz. The dolphin moves in water towards an obstacle at a speed of Vd is equal to 15 meters per second. At 2 meters from the obstacle, it emits an ultrasound signal whose speed in water is Vs is equal to 1500 meters per second. In this animation, d represents the initial distance between the dolphin and the obstacle, which is equal to 2 meters. While the dolphin is approaching the obstacle, the wave emitted moves to the obstacle and then reflects back to be detected by the dolphin. The question is, denote by x the distance covered by the dolphin just before receiving the echo, and denote by t the time needed by the dolphin to receive the echo. Part 1.1. Find the relation between x and t. We have to use the speed of the dolphin, which is given by Vd is equal to x divided by t. Then, by substitution, we find that x is equal to 15 times t. In part 1.2, we have to express the distance as a function of t, x, and vs. During its motion towards the obstacle, the wave has moved a distance d, and in its backward motion, after reflection and just before the instant of being detected by the dolphin, the distance covered by the echo is d minus x. So the total distance covered by the wave is d plus d minus x. To find the speed, we have to divide this distance by the time interval t. Therefore, we get d is equal to vs multiplied by t plus x divided by 2. In part 1.3, we have to show that t is equal to 2d divided by vd plus vs. From the first and the second parts, we have these two equations. We have to substitute x, and we will find that t is equal to 2d divided by vd plus vs. In part 1.4, we have to calculate t. By substitution with d, vd, and vs, we find that the time is equal to 0.00264 seconds. In part 2, after receiving the echo, the dolphin needs some time called response time to make a response, that is, to continue its motion forward or change its direction to avoid the obstacle. In part 2.1, we have to calculate the distance x covered by the dolphin during time t. Using the previous parts, we have to substitute with Vd and the time t, then we will find that the distance x is equal to 0.0396 meters. In part 2.2, calculate the distance dr covered by the dolphin during response time if it is equal to 0.1 seconds. Here we have to use the formula dr is equal to vd multiplied by the response time, which will give 1.5 meters. In the last part, can the dolphin avoid the obstacle? Justify. Here we have to talk about two cases. If the distance covered by the dolphin during the response time, which is dr, is greater than d minus x, then it doesn't avoid the obstacle. But if this distance dr is less than d minus x, then it will avoid the obstacle. So first let us calculate d minus x, which will give 2 minus 0.0396, which is equal to 1.9604 meters, where dr is calculated before, which is equal to 1.5 meters. By comparison, we find that dr is less than d minus x, and we conclude that the dolphin avoids the obstacle. Try to solve these problems alone, and thank you for watching.